if we look at example 3.4, we will see how to apply these constant acceleration equations. So, for example, it says here, you are bicycling at a steady 6 meters per second. When someone suddenly walks into your path 2.5 meters ahead, you immediately apply the brakes, which slow you down at 6 meters per second squared. Do you stop in time to avoid the collision? Okay, so why don't you try this on your own? Pause the video, try it, and then see if we get the right answer. Okay? So, when I don't know what to do, the first thing I look at is, well, I see that my acceleration is constant. Oh, my acceleration is minus 6 meters per second squared. So I know, oh, well, I've got a constant acceleration, so that means I'm able to use these equations. V final is V initial plus AT, X final equals X initial plus V initial time plus half AT squared. And I can also use V final squared, V initial squared plus 2AX. So actually, this third equation, which we haven't derived yet, I'm not sure really if I'm going to do it in these videos, this simply comes from these two equations if we eliminate time. So this third equation is dependent on these two. Nevertheless, the point is this. These three equations we can apply if we've got a constant acceleration. So, if I try to solve this the long way, I can first say, well, let's take this equation and say my final velocity is 0, my initial velocity is 6, and my acceleration is minus 6, and then I can solve for time, and I get time is 1 second. Then I apply this, I plug this into there. Now I've got time, I've got my acceleration minus 6, I've got my initial velocity, which is what? It is 6. My initial position is 0. And then I can get X final, which you'll see is 3 meters per second. 3 meters. Okay? So using these two equations, I am able to solve the answer and say, well, I get 3 meters, and so I'm not going to stop in time to avoid colliding. However, what I needed to do here first was find time and then plug time in there to get my position. This third one eliminates time, and so all I've got is velocity, acceleration, and position information inside this equation. So because I was required to first solve for time here, this one eliminated altogether, and if I use this equation, I'll be able to solve it immediately. And that's kind of what they did here. Not kind of, that's exactly what they did here. They've got delta x is equal to v final squared minus v initial squared over 2ax. So they've just used an equation which is this one. And they are able to then immediately directly get to the final answer. Okay guys, so be comfortable with these three, and recognize that you can only use it if I've got a constant acceleration.